to be learning about special right triangles. We're going to be spending 2 days on this. Special right triangles are, again, and one of those things that are going to be used the rest of your time in geometry and a lot in your other math classes after this. So there are 2 types of special right triangles. One of them is a 45, 45, 90 right triangle, and another is a 30, 60, 90. So if I scroll through here, here's your other one, okay? Now, I know you have this theorem written on your paper, okay? But I want you to understand why it's the way it is, okay? So I'm going to give you an example of a problem using Pythagorean theorem. Now, the one is done for you, okay? Number 2, I believe, is done for you, but I'd like you to just listen, okay? For number 1, it says it on your notes that for this length here, the answer was 7 radical 2, okay? I want you to notice also where this 7 is in relation to the triangle, okay? Notice that 7s are your legs. We have a square cut in half, which forces us to be a 45, 45, 90 triangle, which makes your sides the same. Notice when I did Pythagorean theorem, I got 7 radical 2. Now if I do this with number 2, notice it's a square cut in half, so that means that these angles are 45 degrees, so we have another 45, 45, 90 triangle right here. Okay. Where I have 2 legs are the same, they're both 4. Okay. Now if I do Pythagorean theorem to figure out that length, I do 4 squared plus 4 squared equals x squared. I solve it, so this is from last section. We get 32 equals x squared, square root both sides, and then I have to put it in simplest radical form, which is 4 times 2 if I were to break it down. I have a pair, and sure enough, I get 4 radical 2 as x. I also want you to notice, look at it, it's 4 radical 2. Notice the side lengths were both 4. Okay? If I kind of just make up some here, if this was 10s on a 45, 45, the hypotenuse would be 10 radical 2. If I had another right triangle and I did Pythagorean theorem and these were all 8s, the 2 legs, I know the hypotenuse was 8 radical 2. What a mathematician did is they did Pythagorean theorem for all these different scenarios and noticed a pattern. They noticed a pattern that there's a relationship between the legs and what the hypotenuse is. So notice that the legs are both 8 and the hypotenuse is 8 radical 2. Here the legs are both 10, so the hypotenuse is 10 radical 2. So if I look back at this theorem, okay, instead of doing Pythagorean theorem every time for these certain types of triangles, there's a shortcut. Okay? And part of being good at doing some of your math is being more efficient. And what we're going to start doing more in geometry is trying to get that efficiency to be more prepared in other math classes. So for a 45, 45, 90 triangle, they use L for the sides. Notice the sides are exactly the same. And like what I showed you before, the hypotenuse is whatever the side is times radical 2. Here's a formula to explain that as well. But hopefully, or eventually, we'll get you to look at just the figure to figure out missing side lengths. So if I go to this first question, okay, I'm going to figure out what these sides are. I have to figure out everything on the side, so I think I have a y there. Okay. Now, if it's a 45, 45, 90 right triangle, because it has that 45 there, I know the sides are the same. So I know what y is. Y is also 25. Now for x, remember I saw that pattern. The legs are both 8, the hypotenuse 8, radical 2. The legs are both 10, the hypotenuse is 10, radical 2. The legs are both 4, the hypotenuse is 4, radical 2. Okay? If I'm looking at this picture, I'm going to take that leg and multiply by radical 2 to get what x is. Now the formula we have for this is hypotenuse equals radical 2 times the leg. That's exactly what I was saying. The legs, whatever the legs are that number times radical 2. So if I use the formula, sure enough, when I plug it in, that's what it's going to look like. I plugged in x for the hypotenuse, radical 2 is part of the formula, and your leg. And the radical 2 again comes from the fact that a mathematician figured out that pattern. They figured out there's a relationship between all the sides on this special right triangle. That's why it's called special. So let's try another one. See, on this one, I'm starting with the hypotenuse. So if you think about it, if I need to find the two legs, okay, the other one I started with the legs, okay, notice when I started with the legs, I had to multiply by radical 2 to get the hypotenuse. I had to multiply by it. So if I'm going to go backwards, if I have the hypotenuse and I want the legs, I'm going to divide by radical 2. So right away, you can take 17 divided by radical 2. Again, though, your formula will demonstrate what you're going to be doing with that. Oops. Can't write that yet. Okay. So my hypotenuse is 17 equals radical 2 times the legs are the same, so I'm just going to use x. And sure enough, when I solve this, I have to divide by radical 2, just like what I was saying before. I have to take 17 and divide by radical 2. If I have the leg, I need to multiply by radical 2 to get the hypotenuse. If I have the hypotenuse, I need to divide by radical 2 to get the leg. But when I look at this, this looks disgusting. Not because it's not right, it's because I have this radical in the denominator. So this simplest radical form is what we have to be doing every time with these. So I'm going to multiply by a fancy looking 1. I call it fancy because it's radical 2 over radical 2, which is still technically a 1. So if I multiply across with that, I get 17 radical 2 on the numerator, and on the denominator, radical 2 times radical 2 is just 2. So this equals my x and my y. Next one. Who wants to do this? Here we go. So we need to figure out these two lengths. Y, you should already know what it is because it's a leg, and on 45, 45s, these are exactly the same, so 48. Now this is like the first one we did. We have the legs, now I need the hypotenuse. Well, if we remember back in our theorem, notice that we have the legs, the hypotenuse is the leg times radical 2, also written in the formula. So if I look at this problem, I can use my formula, but hopefully we can get you to know that, okay, if I have a leg, to get the hypotenuse, I need to multiply by radical 2. Why radical 2 again? Because that was a pattern with these special right triangles when Pythagorean theorem was used over and over and over again with these types of triangle. Okay, so I have my hypotenuse is x, and then I'm going to, sure enough, take radical 2 times one of the legs, which is 48. So my x is 48 radical 2, and my y 48. Again, here we go. We have the hypotenuse and I need the legs. So if I have the legs, I multiply by radical 2 to get the hypotenuse. If I'm going to go backwards, I'm going to divide by radical 2. This is the formula to help you out with that. But sure enough, when I plug in these numbers, I have to divide by radical 2, which is exactly what I was saying. So I divide by radical 2, I get x is 100 divided by radical 2, which looks disgusting because of the radical in the denominator, so I'm going to rationalize it by multiplying by a fancy looking 1, multiply across, I get 100 radical 2 all over 2. Now before you circle that, you can reduce. 100 divided by 2 is 50, so 50 radical 2 is x and y because the legs are the same. Here, they give you almost the same problem, only your 100 is on the leg. So your y is 100 because the legs are the same. If you have the legs, you multiply by radical 2 to get x. If you forgot that, you can remember the formula. The hypotenuse is x, and sure enough, I'm taking 100 times radical 2. So x and, nope, just x equals 100 radical 2. My y was 100. Last one, 45, 45. We need to find what x and y are. If I have the hypotenuse, I need to divide by radical 2. If you forget, you can use this formula. Hypotenuse is 88. A leg is x or y. And sure enough, to get x alone, I need to divide by radical 2. And as always, you need to multiply by your fancy looking 1. Radical 2 over radical 2. So I'm left with 88 radical 2 all over 2 equaling x. But I can reduce to get 44 radical 2 for x and y since the legs are the same. So that's 45, 45, 90. You're either multiplying by radical 2 to get a hypotenuse or dividing by radical 2 to get the 2 legs. 30, 60, 90 I think is actually a little harder. Okay? We have 3 different sides. And if you do Pythagorean theorem over and over again for 30, 60, 90, you'll notice these patterns. Okay? What happens is the short leg, so the short leg is always across from 30, the smallest angle, you learned that last semester, is what is the length that will give you all the other sides. Okay, so the goal is to always get the short leg. Once you have that short leg, you multiply by radical 3 to get the long leg, and you multiply by 2 to get the hypotenuse. So if I have the short leg, the hypotenuse is 2 times, and the long leg is radical 3 times. If I start with the hypotenuse, I divide by 2 to get the short. If I start with the long leg, I divide by radical 3 to get the short. Okay? So when you're first learning that, the visual can be a little confusing. So there are these formulas to kind of help you out. There's 2 of them, okay, because you have more differences in this right triangle than you do in the 45, 45, 90. Okay, so for number 1, okay, which is done for you, okay, notice that the short leg here is 4 in this right triangle. This is 30, by the way. Notice your hypotenuse is 4 radical 3, and what I got, or for the long leg, and what I got for the hypotenuse is 8. Notice that the long leg is 4 times radical 3, the short leg times radical 3. Notice the hypotenuse is double the short, which is 8. That's a pattern. If you don't believe me, let's try this next one. Okay, say I need to find this hypotenuse. If I'm going to do Pythagorean theorem, which is already on your sheet, okay, you're going to notice there's a pattern. I get 36. Here I have to distribute the square, so that's 36 times 3. Okay. And then when I add all that up, so I get 144. And then square root both sides, I get 12. Okay. So I get 12. Notice how that relates to 6. 6 is the smallest leg, the short leg. Notice that the long leg is 6 radical 3, so they multiplied it by radical 3. And then the hypotenuse is doubled 6. That's not a coincidence, that's a pattern. Okay, there's a relationship between all these sides. That's what makes it a special right triangle. So if I do an example here, okay, I first need to make sure I have my short leg. That's my goal, is to always get that short leg. And here I have it. I know it's short because it's across from 30. Now the relationship between the short leg and the hypotenuse is that it's double. The relationship between the short leg and the long leg is that it's times by radical 3. If that's hard to remember, you can always start with your formulas. These are your two formulas that were highlighted on the other page. Your hypotenuse is x. Your short leg is 11. The formula is doing exactly what I just said. The hypotenuse is double the short leg. So you multiply by 2. Okay? The long leg, y, is you take radical 3 times the short leg. So my y is 11 radical 3. It works, that relationships work for every single 30, 60, 90 triangle. Number 2, okay? Now this one's a little difficult. Here's my short leg. That's what I use to figure out all the sides, but I'm not given it. I need to figure it out. What I am given is that I have the hypotenuse. I have the hypotenuse. My goal is to always get this short leg. I need to get that y. The relationship between the short leg and the hypotenuse is that if you double the short leg, you'll get the hypotenuse. So if I doubled the short leg to get the hypotenuse, to go backwards, I'm going to cut the hypotenuse in half. So I need to take this 8 radical 3 and cut it in half. If you didn't know that, use the formula that's given, and you'll see how I'm going to just be dividing by 2 anyway. Here's my hypotenuse, 8 radical 3. Then I have 2 times my short leg. When I algebraically solve this, I'm dividing by 2, which is exactly what I said you need to do. So when you divide by 2, you get 4 radical 3 as your short leg. And once I have my short leg, I can figure out all the other lengths in my triangle. So to figure out my long leg, the formula for that is long leg equals radical 3 times the short. That's the formula because that's the relationship between the short leg and the long leg. They're scaled by radical 3. The short leg and the hypotenuse are scaled by 2. So the long leg x is radical 3 times the short leg. Well, the short leg is 4 radical 3. So when I multiply these out, this is like a 1 in front. I go 4 times 1. And radical 3 times radical 3 is just 3. So the length of x is 12. Here, another nice one, we start with the short leg, which is nice, because once I have my short leg, I can figure out everything else. I know the relationship between the short leg and my hypotenuse is double. I just need to double it. I know the relationship between the short leg and the long leg is scaled by radical 3. I just need to multiply by radical 3. Say you didn't know that, use those formulas given to you. There's one. Oops. Not that again. This one. And plug in your numbers. If I plug in my numbers, my hypotenuse y equals 2 times the short, 5 radical 3. Well, didn't I just say that? We are going to multiply by 2 to get the hypotenuse. This is 10 radical 3. It's double, it's times 2 to get the hypotenuse. To get the long leg, you times by radical 3. To get the long leg x, you take radical 3 times the short, which is exactly what I just said on the picture. So I get x equals 5. Radical 3 times radical 3 is 3, so x is 15. Number 4, I'm starting with the hypotenuse. I want to get my short leg. Once I have my short leg, I can figure that out. You look at that last example, I multiplied by 2 to get the hypotenuse. Here I'm starting with the hypotenuse. So to get the short leg, I need to now divide by 2. If I use the formula, okay, and I plug all my numbers in, look at what I'm doing algebraically anyway. I'm dividing by 2 to get x, which is exactly what I was doing looking at this picture. I know the relationship between the short and the hypotenuse is double. I know the relationship between the short and the long leg is scaled by radical 3. If I use the formula, that's exactly what it's saying. It's radical 3 times the short. The short leg is 15. My long leg then, which is y, is 15 radical 3. Couple more. Here I'm starting with the long leg. Remember here, I had the short leg and I multiplied by radical 3 to get the long leg. If I start with the long leg, I need to divide by radical 3 to get the short leg. I always want to get that short leg because once I have the short leg, I can figure out all the sides. So I know the relationship between the long leg and the short leg is radical 2. So if I'm going backwards, I need to divide by radical 3. Okay, so I have long leg equals radical 3 times the short, exactly what I was saying. So 21 radical 3 equals radical 3 times y. And algebraically, look what I'm doing. I'm dividing by radical 3, exactly what I said in that picture. So you can use the formulas, or when you get better at it, kind of look visually at the picture and see where you are and do what's appropriate. When I figure this out now, this 21 radical 3 divided by radical 3, those radical 3's divide out, I'm left with 21. So my short leg is 21, which means I can find all the other sides. I know the relationship between the short leg and the hypotenuse is double, so I know I need to multiply by 2 to get the hypotenuse. If I didn't, I can use the formula route. The hypotenuse is 2 times the short. That's exactly what I just said. Hypotenuse x equals 2 times the short, which is 21. So my answer is 42. Last one. We start with the hypotenuse. I need my short leg. That's always what I'm trying to get. I know the relationship between the hypotenuse and the short leg is double. So if I have the hypotenuse, I need to divide by 2 to get the short. If I have the hypotenuse, okay, it's 2 times whatever the short is. Oops. Ah. There we go. So my hypotenuse, which is 52 radical 3, equals 2 times the short. So if, which is y. Jeez. So I'm dividing by 2 algebraically using the formula just like how I wrote in the picture. So if I divide this out, what do I get? 26 radical 3 is y. Now to get the long, now that I have the short, I can figure out the long leg. I know the relationship between the short and the long is by radical 3. If I look at the formula, long leg equals radical 3 times the short. Long leg is x, then radical 3 times the short. Okay, so what I'm left with is 26. Radical 3 times radical 3 is 3. So my answer is what? 48, I think? No, not 48. 78. Whoops. Okay. So the goal with these is to get your short leg first, and then you're either multiplying by 2 or multiplying by radical 3, depending on what length you need. So look back, you can use the visual of your special right triangles or your formulas.